In this graph, we are given a graph of f prime, and I'm looking for where is f concave down. So remember, f concave down, we start looking at the second derivative, so that means f double prime is less than 0, but I don't have the graph of f double prime, I have f prime. But f double prime less than 0 is the same as f prime decreasing, and this is decreasing from here to here and 4 to 6, so D would be my answer. Next one, number 96. I want to know which of these could be y if we know y prime is less than 0. So what does that tell me about the original? The original graph is decreasing. So that rules out A and D. But then we also know that y double prime is positive, so that means the original graph y is concave up, so that only leaves me with B. Okay. Again, another graph problem. The graph of f prime is given here. I want to know which of the following could be the original graph f in my answer choice. There's a lot of ways to do it. First thing I do is look at my zeros. So notice there are two places where the first derivative is equal to 0. So that means on the original graph, you should see two horizontal tangents line. And this point right here, notice that the derivative goes from negative below the x-axis to positive. So that means the original graph is decreasing, then increasing. So this point is a local min. And then this goes from positive to negative. So this is a local max on the original. So I'm looking for a graph that has a local min and then a local max. So the only one that does that is A. And the last one, what is the x-coordinate where the curve has a horizontal tangent? So remember, when you hear the words horizontal tangent, you should be thinking this. Where is the first derivative equal to 0? So I'm going to go ahead and take this derivative, but I'm going to do it implicitly. So the derivative of x cubed is 3x squared. The derivative of y squared is 2y times dy dx. And the derivative of 27x is 27. Okay, I don't have any points to plug in, so we need to find dy dx. So I'm going to solve this for dy dx. So that means I would subtract the 3x squared and then divide by the 2y. Once I have dy dx, think about what does it mean when you have a horizontal tangent. It means the derivative is 0. This is your derivative. The only way that can be equal to 0 is if the top is equal to 0. So if you solve this for x, the only answer choice that works is 3 for x.